welcome to Oil Tech Pro. We have been on the series of fundamentals of reservoir engineering. We have considered a lot of properties of the reservoir rock, and today we are looking at another critical property, which is the saturation of reservoir rock. The saturation tells us the amount of space available in the pore spaces for reservoir fluids to occupy. So the saturation is a fraction of pore space which is occupied by reservoir fluids. Reservoir fluids, we are talking of oil, gas, and water. And for the saturation of oil, we have it as the oil volume over the pore volume. The pore volume, which is the space within the reservoir where oil occupies. And for the gas saturation, we have it as the gas volume over the pore volume available for the gas to occupy. And for the water, we have it as what? The water volume. The water could be dry and over the pore volume. All these saturations of the various fluids sum up to 1. So we have that for the saturation of oil plus the saturation of gas plus the saturation of water will give us equals to 1. We can relate this saturation to the compressibility. This is total compressibility. Where the total compressibility of the reservoir rock, if you're just joining us, you can go to our previous videos on compressibility. We looked at various types of compressibility, and we are today we are saying that the compressibility can be related to the saturation using this formula, that the compressibility, total compressibility is equal to the compressibility of oil and the saturation of oil plus the compressibility of gas and the saturation of gas plus the compressibility of water and the saturation of water plus the formation compressibility. Okay? This is valid for a saturated reservoir where the reservoir is below the bubble point pressure condition. But above the bubble point condition, above bubble point pressure, we have that this equation will be void of the gas, because at this point the gas has not yet been formed. So gas volume will be very negligible. Okay? And we will have that an undersaturation condition will occur where the total compressibility will be equal to the compressibility of oil and the saturation of oil plus the compressibility of water and the saturation of water plus the compressibility of the formation. So this equation will automatically change, leaving out the gas compressibility and saturation of gas and giving us this for above one point condition or undersaturated condition. And we have this new equation form which we can use to determine for total compressibility. So if you are given any of these values for compressibility, we can determine the saturation of our fluid or that particular fluid. Now, typical saturation of various reservoirs in the world. Typical saturation of various reservoirs. We have that for our clean or clear sandstone. For clean or clear sandstone, we have a saturation of between 10% to 20%. For shaly sandstone, we have conditions of from 30% saturation to 40% saturation. Now, for our cold bed methane, which we have a lot of them in this axis, so for cold bed methane, we have a saturation of 100% saturated, and so on and so forth for so many other forms of reservoirs that we can encounter. Join us in more classes as we look at other aspects of reservoir engineering. In case you have not liked or shared our page, please do so and share and comment, and hope to catch you in our next class. See ya.